So hi, thank you for joining. This is your inventor, Nandom. You're welcome to this class. This is the continuation of the class components and instruments. In the previous class, we discussed the multimeter. Today, we'll see how we can use the multimeter to test resistor, and also we're going to look at how we can do basic calculations to determine the resistance of a resistor. So when we say resistor, what do we actually mean? A resistor is an electronic component that limits the amount of current that flows through a circuit. Now, that is so important because at certain parts or portions of circuits, we could have currents or voltages that could go quite high. So without resistors, damage could happen in the circuit. Now you can see there on the screen the symbol for the resistor, and it's important to know such so that in case you see it in any circuit diagram, it will be easy for you to know that it is a resistor. Now we have various kinds of resistors. This is based on their design or based on the material used in making them. Now we have fixed resistor, it's a type of resistor. We have a light dependent resistor, we have variable resistor, we can have the surface mount resistor, and then the wire wound resistor. There are many other types of resistors. Now we'll be focusing more on the fixed resistor, and particularly the carbon composition resistor. I have with me three of them, three examples. They are of different types. Of course, I'm going to talk about them a bit later. Now, something fascinating here I would want to mention. Maybe you never knew that even the graphite or the lead, which is of course the core of your pencil, the normal pencil is also a resistor. It has its own resistance as well, and I'll show you. So now I have my pencil and my ruler, so I'll be drawing a thick straight line to demonstrate that the graphite in this pencil or the lead can act as a resistor. So I draw my line this way. So I think the line is thick enough. Then I turn on my multimeter, calibrate it to resistance test. Now we have our multimeter on, so I can put any of the polarities on either of the sides. I can, I have the red one to my left, so I can place it here. I can flip it to the other side, no problem, since resistors don't have polarity. So I place one on this line, and then at the other edge I have this. So you can see, if you can see the multimeter, I have 1.165 mega ohms. Wow. So that's the resistance of this line. So you can see that the core of this pencil acts as a resistor. So let me close up on the distance and see if the value changes. Don't forget, here we have 1.165. so I take it further closer. Okay, so you can see that the value drops. This is 0.735 mega ohms, 0.732 thereabout to 5 mega ohms. So the closer the line is, or the shorter the line is, the smaller the value of the resistance, but of course it's in mega ohms. So this demonstrates or clearly shows that the core of your pencil acts as a resistor. So we'll be looking at the resistors that I showed you earlier. I have three of them. The three of them are fixed resistors, but they are of different values. So I can actually calculate the values of these resistors, and I can actually use my multimeter to test them. So the calculation will be displayed on the screen as I explain. Afterwards, I will use my multimeter to test, so you can see how close the values are, if they are the same or not. Okay, so before we calculate the value of this resistor, there are things that are very much vital about resistors, fixed resistors, and I would want to let you know. Now, this resistor, for example, has 4 color bands on it. We have the first band, the second band, the third band, which is the multiplier, and the fourth band, which is the tolerance of the resistor. Now, the tolerance is usually silver, gold, or you get to see a white space. Now, to this side, I have gold color. So if I want to calculate the resistance of this resistor, I would begin with the color on the opposite side of the resistor. Now, in a situation where I don't have any color here, but then I have white gap here between the multiplier or between the one of the colors and then the edge of the resistor, as long as there's very white margin or white band, white empty band, then I will still have to start calculating or start counting from the opposite direction. So now I have the first one here on the opposite side to be brown. I have black, then I have brown. So I have brown. Brown here is 1 from our resistor color code chart. Then the second one is black, and black is 0. So the 0 has to be written just beside the 1. That would give you 10. Then we have another brown, the third band, which is the multiplier. And this multiplier is 10 for brown is 10. So now we have 10 times 10, and that would give you 100. So this simply means that the value of this resistor is 100 ohms by calculation. So let's test this using our multimeter and see if we will have any value that corresponds to what we just calculated. So I just calibrated the multimeter to resistor test. Now I would want to use nose pliers to bend the terminals of my resistor so I can lock my probes onto it. Now there's a reason why I'm doing this. Is because I don't want to hold on to the resistor when I am carrying out the test. Now my fingers or my hands contain some level of resistance or some level of impurities, so it may affect my measurement, and I wouldn't want that to happen. So let me just lock it this way and the other one locked this way. So if you look at the multimeter, this is what we have. We have 98.6 ohms or 98.7 thereabout, swinging between 6 and 7. So this is very close to 100. So it shows that our calculation is very correct, and then we are accurate. Okay. Now the next one is actually similar but different color. So here you can see here we have another color which is gold at the extreme. So we start from the opposite direction or opposite side. So here we have brown, black, then red. So the brown here is 1, so the black is 0. Now this red, the multiplier here, which is the red, is 100. So we have 10 times 100, which is 1000. So this is 1000 ohm resistor or 1 kilo ohm resistor. The same thing, if I'm to measure this on the multimeter, we're going to get the same value as calculated. Now the third one is almost the same thing but different color bands. Here I also have gold at the extreme. So on one side here, the opposite side, I have brown, I have black, then orange. So brown is 1, followed by black, which is 0. Then that is 10, 0 beside the 1. Then we have orange, and orange here is 1000. So by the time you have 10 times 1000, that would be 10,000. So this resistor is 10,000 ohms or 10 kilo ohms. So I hope you are actually following, and then our class is quite interesting. Now there are so many applications of resistors. Don't forget, I mentioned earlier that resistors are used to limit the amount of current flowing through a circuit. Before we continue, let me just turn off the multimeter to save our power. Okay, so resistors are used to limit the amount of current flowing through a circuit. Okay, but there are other applications. For example, we can use our resistor as voltage divider. Of course, where you have large voltages within a circuit, you can use a configuration of resistors in series, and then across them or across one of the resistors, you can actually get a lower voltage as compared to the terminal voltage you might get at either of the points that serves as a source. Also, we can use, as mentioned, resistor practical application now to limit the amount of current as stated earlier, but for example purposes, maybe an LED. So we're going to be simulating all this for you to see using every circuit software. Sorry, you can have your resistor in half watts. You can also have your resistor in quarter watts. So resistors can be in half watts, can be in quarter watts, can be in 1 watt, and then can also be in 2 watts as the case may be. So the watts stands for the amount of power that the resistor, or the amount of energy the resistor is capable of dissipating. So absolutely, when you're dealing with high power applications, then you would want to go for resistor with a higher power. Okay, so in our application of resistors, we'll be looking at 2 examples. So we'll start with the voltage divider. So for the voltage divider, I'll be using 2 resistors, both of them 1 kilo ohm. So I connect them together this way, and then the power source, which is a DC power source, and this will be connected to the other terminal of the resistor. The ground has to be connected, is very important. Now, looking at this, the voltage here is a bit too little, so I would have to increase the voltage to 9 volts. I can use a different voltage setting, but this is what I have chosen. Now, let me simulate. So by simulating, you can see those green dots moving. That's my current flow. And then in between the 2 resistors, you can see we have 4.5 volts. Okay, before I conclude on this, let me use a voltmeter to test what I have. So this is my voltmeter. Now one terminal goes in between the 2 resistors, the other terminal goes to the negative or the ground. Okay, so now let me simulate. So by simulating, you can see what I have. At the voltmeter, I have 4.5 volts. Now at the source, we have 9 volts. So by the time we multiply 4.5 by times 2 or by 2, then we would have 9 volts, indicating that it is a voltage divider. So multiplying our 4.5 times 2 of the resistors, it gives us the value of the DC source. Now if I were to use 3 resistors, I would get some other values that by summing them up, I would get the value of the DC source. So this is one application of the resistor. So let's look at the second one, which is a resistor as a current limiter. So now let me import my LED. I'll be making use of an LED. So I have an LED here. First of all, I will be using the LED without a resistor. So we can see what happens. This is 1 volt, a little bit too small. So let me raise the voltage to 9 volts. Okay, so by the time I click on simulate, now you can see what happens. 9 volts is too much for the LED to handle. So now let me stop this. In between, now connect a resistor and see what happens. So I have 1 kilo ohm resistor connected to the LED. So now we go on simulate. Now you can see the LED is running smoothly, but the LED is not too bright. So I can increase the brightness by reducing the value of the resistor. So let's say I'm dropping it to 500 ohms from 1 kilo ohm. So by simulating now, you can see that our LED shines brighter. If I want it to shine even brighter, then I would have to drop the value of the resistor, but I wouldn't go so low so that the LED does not rupture. So these are two key applications of the resistor. Thank you for watching this video. Kindly subscribe to my YouTube channel if you haven't, and please drop your comments and let me know how you feel about this video. And if you have questions, please let me know, and the appropriate answers will be provided. Take care.